Welcome everyone to this last video lecture in this series of a short introduction to the OCaml programming language. And my name is David Broman, and today I'm going to show you a little bit about side effects. In particular, state some things about exceptions when they're handled, and also some basic input-output to read from standard input and to write to standard output. And we are also going to compile, first the hello world program and then to do this extension with the input output. So you get some feelings of putting things together. We will not work on algebraic data types and so on in this, but you can of course incorporate that into your compiled program. But let's start again in the Try OCaml environment to just look at exceptions. And maybe we should first look at the libraries here. So let's see here, if I can go to this there, the API. And so if we look at some example here, say look at the list, and let's see here, we got a list and this nth function that we used. So it takes as input a list, and you pick out the index element given there, and then you put out the element. What if you're outside the actual range of this list? Then it says in the documentation it will raise an exception. So it says that the exception will be failure or invalid argument. So if it's the list is too short, or if n is negative. So if you're outside, outside the bound, you will get one of these errors. So let's try this. So we can try it on the top level, and then we say that just a list nth, and we have some elements 10 to 9. Let's see here, and then say that you want to pick element 8, which is outside, right? You get a failure. It says failure and then n. Okay, so if you write a program, of course you want to be able to catch this exception, and you do that with what is called the try construct. So let's write a function that wraps this and do this nth, but do it in a safe way. So we call that a safe nth, and we want to then to return an option type if we got an element, or none if we did not. So let's see here, last end like this, and then we write try. Then we try to do something, and in this case we want to write list end. So we want to try to do the list end. Last, we want to take the or the list, and then the end. So this is what we try to do with. So this is, we try to do this, get this element out, and if it does not work, we catch the exceptions by stating which exceptions. And as we saw here in the documentation, we saw there is either failure or invalid argument. And failure has got one parameter, which is information about the failure, but don't care about it now. And invalid argument, and we ignore that as well. And if that happens, we want to return the option type none. If it worked, we wanted to return the sum. So this means that we also need to do like this here to return sum. So then we do this in a safe way. So we catch the exception here and just return sum or none. So this, maybe you ask why is not this the default one in the standard library? Well, the exception is that it's as long as you don't get an exception, it's pretty neat to just pick out elements. And in this case, since we're returning sum and none, you need to do this operate on that sum and none afterwards, which actually might be the preferable way of working on it. So it's up to you how you want to design your program. But let's just try this, and then we can do this again, but we use the safe end, and then it says, okay, none, we didn't get an element. But if we say that we want to pick the second one or the first one, we pick that element, and then we got some value. So here now you can see how we can go to use this different kind of error mechanism. Either we use some or none, or some algebraic data type, or we would use exceptions, and we can actually go back and forth with them using try and it's like try catch, but it's called try with to catch the raised exceptions. We can also define our own exception, and that is basically done just by using the keyword exception. Exception, like this, and you can call it whatever you want. It needs to start with a capital letter, exception, and you can also provide other information here, like you can do with an algebraic data type. So this is what is done on the failure. You can have a string explaining the exception and so on. And then you, in your program, when you want to raise the exception, you just do this raise exception, and then you state what you want to do with the exception, like my exception. We can actually do it now in the, we have the exception, and then we can do raise my exception and some string. We need to put a parenthesis around this as well. And we raise that exception. And we can, of course, then, if we raise that somewhere, we could just catch it, right? Using the try. Okay, that's what I wanted to just say about exceptions. So now let's, we will use exceptions actually in this program that we are going to write. So now we're going to write this in an editor and then compile it. And you can use, of course, your favorite editor. I'm just using Emacs here, and we are going to write some program and compile it. So let's start. Before I start here, I just want to make kind of a hello world program here, so that we can start off to show how to write this. I just call this program now my.io.ml. So you create it as an ML file. You write as you did in the editor in the REPL and the try OCaml. You just write the text here. We can start by having a let. So it evaluates all the values to the right of it let in the beginning. So I typically just call this main, but it can be called anything. And what we want to do, well, let's do a hello world. End line, hello world, and save that. And then you want to compile it, and you can use the more fancy build system in June, but I actually like, for small programs, to use the thing that has been around for a long time, OCaml build. And you need to install that to install OCaml build, because it doesn't come anymore as a default. It was default before, but now you have to install it like this. And you invoke it just by just calling OCaml build, and then you provide the program. So in my case, it's my IO. But instead of writing the ending of ML, you say, how do you want to compile it? You can either do it with bytecode or generate native code. And I decide to do it natively. And if we run this now, it will generate a file, but we can actually both run it, compile it and run it in one at once. And then we do the dash dash. It both compiles and runs it. And it compiles and runs, and it prints out hello world. Okay, if we show what kind of files we have a build directory, so it generated this build directory now, and it also has this generated a native program. It's called .native. So you can also call the program directly again, right, to run it many times. And OCaml build also have a cleanup here, so you can write this like this. And then you see that we have all the files have been removed. And this is just generated by the editor. Okay, so we have a start here. and we can just rerun it like this. And let's see here. So now first, what do we want to do? Well, say that we want to write this program here, and we want to have some information from program arguments. We get this information from the something called in the system module, where we get all the arguments. And let's see here. So we remove this and then instead get this sys arguments, sys arg v it's called, and it returns an array of all the program arguments. So what we can do then is to, first thing would be, for example, to write and see what is the length of this array, and then we have to use the array module, which has a function called length. And let's do it like this. Let length in length, and then we say open printf, and then we do printf len equals to d. So we're getting the length of the arguments here, and we are printing the number. So we did not give any argument right now, but we got it to be the 1. If I would have written something here, this is hello in Swedish, by the way, it says 2. So you see that it's one more thing that is there than the argument, because if you we have three parts. This is the same thing as you have been writing, running the program like this. Hi, wow, right? So what comes after dash is if you would run the program, but now with OCaml build you can write this on one line. So we'll do that for now, just because it's simple. Okay, so we have two things here. So what is in the first and second thing here? Well, we can of course print this. Let's print that. So let's print the first element, and let's do that after. So we can use print s, which prints that, and then we do a new line again. And we basically just pick out that element, and there is a function called array get, and then we have to get the sys arg v, and let's say pick out the first element, which is index 0, and run that. So I wonder what comes out there. Well, this is standard in Unix. It's basically the thing that was available in the first in argv is the name of the function of the program that is executed. So if I do like this and take the second argument, and now when I have a second argument, wow, it will print out that wow, right? If I run this without this, you get a error, array out of bound, because you were picking something outside the array. So you have to check the length that it conforms to your program, so you don't get this kind of messy output. Okay, that's about getting arrays. We will use this later on in the example to get some information here. But now let's write this other program and other part of the program. So we just remove this for now, and just this length. We have that, yeah. And then we want to create a new function, but let's show how you can do that. You can write this in a different file as well, of course. So let's write this other function in another file, and we call that function or that file echo.ml, like this. So now we created this file, and then you open up with echo. So you open this file, and it needs to be named like that. There's a capital letter here. And we actually create now a different module. So it will be separately compiled. So it's good to divide your program into separate files, because then OCaml build will automatically separately compile it, and it will faster recompile things done automatically. You don't have to write any makefile or anything. So just in the echo, let's just write first the function hello, and let's say that it returns a number, just adding number, and that instead here, now we printed the length there, say that we are now calling hello there instead. All right. So now we call echo. Inside echo, we have this function hello that adds a number with 1, so we should return 6 here, and then we should print 6 instead. Let's see if it works, if we compile. Now it gives a warning here because we are not using length, right? That's fine for now, but it just helps us to forget that we should use things that we define. But what is interesting here, that it was actually calling this and executing this, and we got the value 6. And note also that we could, instead of opening up this one, we could write just echo, as we have done before in the example. We could have written that. And if we compile that now, it also works, right? But then we could do that without opening it up. Yeah. But let's keep it like this and do that. And we return here. So we will call functions, but will not have this other function. It will not be hello, but we'll write another function here. You can just see here now we can compile and get it to work as we did before. In this function, we will use printf. So we'll also open up printf. And what we want to do now is to read lines from the command line and echo them back. But we also want to print the strings, the line number. So let's call this. It's just a demo, a simple function. So echo lines. We call this one lines. We will have a parameters called space. So if this will be true, a true false. If it's true, we'll add a space in between each printout. Otherwise, we'll not. Just to demonstrate a little bit more on the command line arguments, how we use that. And then we do a let rec. So we do this internal function, recursive function, work, we just call it. And n will be the number when we are counting the line numbers. And we will use then a function called input line that reads one line, but it also have an exception. It also throws an exception when we are at the end of the file. So we'll use that. So we do the try, as you know, that it will catch through the exception. And we can actually write the last part as well. And we will write the actual code inside here, but with, and then end of file. And we'll do nothing if we reach the end of file. We can finish off the function here that we will call this work with 1. So we'll start with that. We'll start at line 1, and then we'll just count up. So this work will be recursively called here. Let's fill in this part. So let string. So we are now getting out one string from the standard input, and there is a call here, a function call called input line and standard in. So we can just see here in the documentation, where do you find this? Well, it's in the standard lib here. We can search for input line. Here it says that it should have an input channel and then return a string. And then we see that it raises an end of file when you have reached the end. So you can look around here. You can, read binary files and so forth here. So let's go back here. And you also see this in that we want to go from the standard input. You can use this input line also when you're reading from a file. Then you have to create the, open the file and read from the file. Okay, we get one line. And let's say that we just want to echo it back, but we also want to print this line number. So then we have a %d, and if we want to have a, a line new with a space, we can actually say that occupy 3 characters. Then we get a nice column. We write, say, a colon there. Just we want that, do that, and then %s. We print the string, and then we have a new line. And n here then will be the number, and then we have that we print out the string that we just read in. Okay, and then with this space, we said that, oh, let's do a space, print a space. If this argument was true, we do just space there, if space, then, and then I just do a print end line, nothing. So this will then be one extra space. Okay, and if we want to use this interactively, at least on Mac, you also have to flush the output. So it's sent to the terminal. You don't have to do this if you're just running the batch mode, but if you're like reading one line by line, it will not otherwise echo until you have finished everything. And then we want to do the recursion. And we are increasing the number here in every iteration because we want to print out the line number here. So as you see, there is no end of the loop here. So the only way it can terminate is actually by this exception. And that's when we are jumping out of the loop and terminating the recursion. So we're terminating the recursion using this exception here. So that's it, basically, what we want to do. Let's call it now, try it out. We can just do it the first thing we do. So what did we call it? We call it echo lines. And just say false for now. That we're echo lines, but we're not giving in a space. And see if we can compile this. We could not. Let's see here. Unbound module printf. Pinf, you see here, I misspelled it. Maybe you spotted already. See here, might be more errors. Oh, no other errors. Okay, and now it waits for some input. Hello, I write. And it echoes hello with number 1. Wow. Echoes 2. Yes. Echoes 3. Right. And then we can end. And if we create a text file here, t.txt, we can basically just say here we got a t.txt, and let's try some. Hello, might work. If so, wow, very, very interesting text. And then you can cut this text. So you, like this, you list it, right? And if we pipe this into our program, we will get it to print out all the numbers and do this formatting as we wanted. Okay, but we also wanted to do something with this program argument, right? So in the main file here, I wanted to use this array length. So I want to now to do this, I want to show that if we write like this, space here, if we write space like this, we should actually give a space, otherwise we should not. So this would be the task here. And how can we do that? Well, we could, for example, try to extract this space here. So let's call that space equals, and we do this length here. We get this length, and we want to also give, incorrect, say that it's incorrect program arguments if we do not use the right way of handling the length and so forth. But we also want that if we don't provide the space, we want to have the semantics that then it should give the right message. It should not have a space. So let's say if we have length equals to 1, which means that there is no program argument, so no, then return false. Then false. So it means that space will be false. And then we can say else if length is equal to 2. And so we have the shortcut. It will first check the length is 2. If that is the case, then we'll do this. So then we are safe to do an array get on system argv1. So we pick out that one, this first element. And then if this is equals to space, so we say that the first argument is actually a space, then we return true. Else, we know that we have some problems. So let's do this. You do a print end line saying incorrect program arguments. We will print out and say this is not correct, and we want to give another exit code. So by default, if you don't exit the program, it will exit with 0, but otherwise it will have an exit code of something else. And now we say that we exit with 1 because it's an error. And this is what we want to do. And then we have in. So now we have defined space to be either true or false, or we give the error message. And then we want to invoke this function here in the end instead. And we don't need this. And instead of always false, we say space here. So we'll invoke this with either true or false. And let's see if we can compile this. And I just compile it without running it. Okay. So now let's do this again with the cat here. If we do say that we have space here, we will do give space. If nothing is done there, it will do like this. If we have an incorrect argument, it will say invalid argument. If we have space with more than one argument, it will also give incorrect argument. Right, exactly as we wanted. So we have showed many examples here. I mean, it's just a simple program, but I think it illustrates many aspects. So for example, reading from the standard input, writing, formatting output. We can show here, we showed how to read input. We have to format using printfs and so on. You can look up this in documentation. You can do it many different ways. We showed how to use exceptions here, try, with, and this was actually terminating the output. We illustrated this flush that you need to do when you're doing this interactively, because otherwise it will not print it directly. We showed just how to use a module here. It does automatically separate compilation. There is something called .mli file that you can use if you write a larger programs if in that way you can hide. So now when you write a function, all functions are exposed to the outside world, but then you can hide and just show the ones that you want to. I don't show it now, but you can take a look at that. A little bit about how to use arrays. So we have these arrays here, and you can look in the array library how to do many things with arrays. So the difference with arrays and lists, I forgot to tell you, is that arrays are you cannot just extend them with cons in the way. It's more expensive to extend them because it needs to create new memory. And arrays are also mutable in OCaml, whereas lists are not mutable. These are some of the things that I showed in this last video, and there might be coming more advanced videos in the future if people are interested. So again, thank you for listening, and I hope you learned something during these sessions. Thank you.